Okay, hello everyone. Thanks very much for having me and for coming here to listen to a scientist. I've been told, and you've just been told that I'm the first one in this series. So it's kind of a responsibility, scientists speaking about ideas without equations, that's hard. And I promise there will not be a quiz in the intermission. I have nothing to do with these questions that they're talking about. So what I want to talk is about us. And let me start the story in 1543. So in 1543, there was this very shy canon of the Catholic Church in Poland called Nicholas Copernicus. He was dying because he had a stroke. Now, before he died, he spent 30 years of his life trying to figure out what the universe was like, right? Because before him, since we know, even before with the Greeks, people thought the earth was the center of everything, right? And there was a beautiful order to that. The earth was the center, and the moon went around the earth, and the planets went around the moon, and there was this sort of verticality that was very appealing to everybody. It was appealing to the church because, as you know, when you go into a medieval cathedral, what you do is you look up, right? You ascend in grace to kind of commune with God. And so the structure of the universe reflected what the religious people thought about and the way they lived their lives. So it was a really big deal, right? And what he wanted to do, being a canon of the church, was to revert the cosmic order. He wanted to change the way people thought about the universe and by consequence about themselves, right? You have to have a lot of guts to do such a thing. Now, the problem is that he wrote this book and he gave it to his only student. He only had one student. He was a real recluse. And this student was a homosexual who was kicked out of the town and went in search of a publisher. In those days, it was kind of hard. You had to take your manuscript to the publishers, and there's a bunch of publishers here tonight, so it's kind of interesting to mention that. And he ended up in Nuremberg, right? And he got to Nuremberg, he found a very good publisher there, and it turns out that he was kicked out of Nuremberg again. And he gave that manuscript to a theologian who was a Lutheran theologian who was very much against the Copernican ideas, a guy called Andreas Osiander. So what did Osiander do? He picked up the manuscript and added an anonymous preface to the manuscript, which basically says, "Do not believe anything that is in this book. This book is just about a calculation, a theory that has nothing to do with the reality of things. Because as we know in the scriptures, the earth is the center of everything, period." He didn't sign that as Copernicus, but it was implied that Copernicus was saying that. So the story goes that Copernicus gets the manuscript finally printed in his bed, right? He had a stroke. He looked at that thing, who basically annihilated 30 years, his whole life work, essentially, and he died that very same day, right? So the stakes are really high when we're talking about the order of everything. And it took about 60 years for this notion that it is not the earth that is the center of everything, but it is the sun that is the center of everything that really matters, right? And now you fast forward a few hundred years, and you go to the 20th century. And here we are in the 20th century, we have a completely different vision of the universe, right? We have learned so much about the universe. Science is an amazing thing. You look at amazing pictures of the very large, galaxies billions of years away. You look at the very small, all your gadgets, your iPhone, your GPS, all of that depends on quantum physics. So there's no question that the more we understand about the universe, the more our lives are being transformed by science. And I'm not even talking about the biological science, which would be a completely different ballgame and a different talk as well. But you then get this sort of false sense of confidence, that science can understand everything, that there is an end to knowledge, that we have this triumphant march towards understanding the secrets and the mysteries of nature. And it turns out that that kind of dream of understanding everything is false. You just cannot, right? And the way you cannot is the following. if you understand how we learn about the universe, how do we learn about reality, right? You guys are all here listening to me, so you can see me, you can hear me, and then you say, yeah, my brain is integrating all this information, and through this amazing integration that happens in this tiny little mass in your heads, you actually know that this is real. But you know what? This is only a very tiny fraction of what reality is about. Reality is full of what we do not know. As the fox told the little prince, you know, what is invisible is essential to the eye. And science is exactly about this. It's about opening these windows into this invisible reality that we cannot see with our senses. And so we create instruments, right? So we create the microscope and the telescope and a bunch of other detectors. And sometimes the guys that invent this discover that through those new instruments, you reveal a whole new realm of reality that you could not have anticipated. You know? So the way knowledge progresses is through surprises. So if you think of this knowledge as an island, right? So you have the island of knowledge. And as we know more about the world, the knowledge expands. Sometimes, you know, you have ideas that you think are right, and they shrink because they're not right. It just has happened in my field in cosmology. You know, there was this big brouhaha in March that we discovered these fundamental waves from the Big Bang, and it was in the media everywhere, and it's incredibly embarrassing that it's all BS, essentially, you know. It's wrong, right? It's a completely different way, a much more mundane way of explaining what's going on. So in a sense, that's how science is done. You know, you come up with these ideas, with hypotheses, and then you go and you further test them. But on the other hand, what this is telling you is that there is no final, firm scientific knowledge. There's just an evolving ideas, right? So if you want to think of, okay, so since reality is full of these invisible things, not just what we can see, can we even know reality? Can we get to the end of things? Can we get to the bottom of what this is all about, right? And the answer is no. You cannot, right? Sorry, guys. And the reason is again, the following. Look at a telescope or a microscope. The way we look at things depends on our instruments. I call them reality amplifiers. You know, they sort of open windows into this stuff that we cannot see. But every instrument has a limit. You can only see so far. You can only see so small. And that is always going to be the case. There is no perfect instrument that is going to open up reality with all that it has to look, you know, to offer us. And so there is always this sort of myopic approach to what reality is about. So there is this French philosopher from the 17th century called Bernard Le Bovier de Fontenelle. And he used to say that all philosophy is but two things: curiosity and short-sightedness. And that is exactly right. We have this urge to understand, right? We want to understand more and more and more about the world, and yet we can only see so far. We cannot see the whole picture. And from this tension, from this urge to understand and not being able to, is where we have all this creativity, right? So Einstein would celebrate the mysterious as the stuff that is behind the impulse to create, both from a scientific perspective and from an artistic perspective. You know, the mysterious is what basically moves us forward. We want to know more about this invisible thing that is out there. And there is this very seductive relationship between our imagination and this unknown, right? And so you go back to Copernicus, right? And what Copernicus did, and then after that, what has happened is that the more we learned about the universe, the less important we became, right? Because first we were the center of everything. That's just awesome, right? The earth is in the middle. We're created in the image of God. We're the best. And then the Polish canon says, sorry, no, we're just a planet. And then there are other planets. And it turns out that Jupiter is much cooler than we are because we have one moon, and Jupiter has more than 60, okay? Now, that's humbling, right? And can you imagine the night at Jupiter, how awesome that could be? So it just must be amazing. Too bad you can't stand on the surface because Jupiter is a gas planet, so you just sink. And it'll be real cloudy, you couldn't see a thing unless you floated, you know. But the point is that you learn all these things, and now there is something quite remarkable going on that you may have heard of, which is that we know that most stars have planets, right? So it's not just the sun is special because it has a solar system, like the queen with the court of planets around it. No, most stars have planets. And now you look at our home in the universe, which is, from a cosmologist's perspective, the galaxy, the Milky Way, So we think big here, right? So the Milky Way is where the sun is, and there are about 200 billion other galaxies in the sun, 200 billion other stars in this galaxy alone. And there are about 200 billion galaxies in the universe as a whole, okay? Now, that is really humbling, right? So that says, really? So there's the sun, there's this little planet, this little blue planet where we are, but then there are billions of others. And if you start thinking that all these stars have planets around them, and there are moons, and now we also think that there could be life in other moons. Just to give you an example, which is really amazing. So one of the moons of Jupiter is called Europa. Europa is about the size of our moon, and it's a world covered in a crust of ice, which is about a mile thick. Underneath that crust of ice, there's an ocean of salty water, just like ocean water, right? With 4 times more water than all the oceans of the earth combined. Okay, so it's like a huge floating water bubble, in the sky, so to speak. And so people are thinking, hey, water, that's what we need for life, right? So where is life? Where is all this life out there, right? And so we are looking for life. And people think of the so-called Copernican principle, which is also known as the principle of mediocrity. Now, that's really insulting. Basically, it says that we are just nothing, really, right? We are just like this little planet, and there'll be a ton of others out there. Well, it turns out that that's not quite so simple. It turns out that when you start to look at the other planets, you realize that this planet is really very unique for a bunch of reasons, right? So, for example, the fact that we have a single moon, and it's a big, heavy moon, allows us to have the 4 seasons. If the moon were not there, what would happen is that the Earth is like a little spinning top, right? It's spinning around like this. If the moon was not there, the Earth would be spinning like crazy, and there'll be no seasons. And guess what? If there are no seasons, there is no stable temperature. The temperature would fluctuate like crazy. Water would freeze. Water would melt in completely random ways, and life as we know it would not be possible. So when you start to reconstruct the history of what has happened on planet Earth for the last 4 billion years, you realize that for life to go, first of all, for life to show up, right? I mean, how the heck does that happen? If you think of the transition from atoms, non-living, stupid atoms, right, that somehow get together and make cells, and those cells are living. Now, for 3 billion years, that's all Earth had. It had simple cells. And then suddenly, they decided that, united we win. Let's put 2 cells together and 4 cells together. And then you have multicellular organisms. And then because of the multicellular organisms, we were able to have more complex organisms with different organs. And then you have the dinosaurs, right? And after the dinosaurs, the mammals dominated, because dinosaurs, of course, were destroyed by a huge asteroid that killed 50% of life here about 65 million years ago. And so you get to our story, and you realize how our story is completely contingent on what has happened to our planet as well. So life in a planet depends on the life of the planet, right? How it evolved in its history. And you start to look around and realize, what? Earth is very special. Earth is unique in many, many ways. And there is more. Distances are so incredibly vast that there is no question that if there is life out there, and there should be simple life out there, intelligent life, if it exists in our galaxy, will be so remote that we are alone. So it is the total reversal of the Copernican idea, is that actually we are incredibly important. We matter because we are very rare, because we are these thinking creatures that can build telescopes, write poetry, and real funny books, like you're going to hear soon enough, right? And we know that we can figure things out by ourselves. So, as Carl Sagan used to say, we matter, and we are the way the universe thinks about itself. Now, even though we can't know everything, because the island of knowledge is surrounded by the unknown, and we cannot penetrate all of that, that is actually liberating, because that will keep us always curious, trying to know more and more about who we are and about the mystery that surrounds us. Thanks.